Hi everybody, welcome to the third part of fundamental structure of the atom. We've done the first video and second video. The third part of this topic, which could be the final part, we are looking at isotopes. Isotopes. So what are isotopes in chemistry? We said that isotopes are atoms of the same element with the same atomic number but different mass numbers. So the word isotope refers to atoms that belong to the same element. However, they have the same atomic number but different mass numbers. The concept of isotopes or isotopy disproves one of the basic assumptions made by John Dalton in his atomic theory. That assumption says that atoms of the same element are exactly alike and differ from atoms of other elements. When Dalton made this statement, he had no idea that atoms of the same element can differ from each other. That means isotopes were yet to be discovered in the 18th century. So, the discovery of isotopes like chlorine, for instance, the element chlorine has two atoms, isotope 35 and isotope 37. You look at them, you see that these are atoms of chlorine. They differ in their mass numbers. That means they're not exactly, even though they belong to the same element. Then also differ in their number of neutrons. Neutrons, 35 minus 17 here is 18. 37 minus 17 here will give you 20. Then we look at oxygen. Oxygen has 3 major isotopes. Oxygen 16.8, oxygen 17.8, and oxygen 18.8. We look at these 3 isotopes of oxygen. Why are they called isotopes? They have differences in their mass numbers and also in the number of neutrons. 16 minus 8 here will give us 8. 17 minus 8 will give us 9. 18 minus 8 will give us 10. Different number of neutrons. Okay, to look at hydrogen. Hydrogen has also 3 major isotopes. Hydrogen 1, known as helium. Hydrogen 2,1, known as deuterium. Hydrogen 3,1, known as helium. These are types of hydrogen, and you look at them, they also differ in mass number, and also this one has no neutron. 1 minus 1 is 0. This one has 1 neutron. 2 minus 1 is 1. 3 minus 1 has 2 neutrons. So this is the concept of isotopes. Isotopy is a phenomenon. Why isotopes refer to the atoms. Now, looking at this, you see this isotope. The question is, isotopes of the same element, they have similarities. At these 2 isotopes, let's just look at chlorine for instance. Do they have similarities? Yes. What are their similarities? They have the same atomic number, 1717. They have the same number of protons. As we say, atomic number of protons. They also have the number of electrons, being electron. So I have the same atomic number, have the same protons, the number of electrons. Then they also have similar chemical properties because they have the same density. For instance, this one, the configuration is 287. This other one is also 287. One metal and the electron atom will share one. They have similar values. Then, do they have differences? Yes. They also have differences. Isotopes of have different numbers. You can see that 5, 7, 6, 8, 1, and 3 different mass numbers. Another difference is that they have different of neutrons. Take this one out. 35 17 gives you the neutron. 37 17 gives you 20 neutrons. Different as well neutrons. The neutrons stand for different physical properties. So having done that, we now look at what is known as relative abundance, relative or isotopic abundance of an isotope. Every isotope contributes a percentage. For instance, this is chlorine. Chlorine 3517, chlorine 3717. That has two major isotopes. When we go to the periodic table, a chart where all the elements are represented, we don't see the two isotopes. Even if element has 5 isotopes, you only see one symbol represented there. So for chlorine, for instance, let's take one for instance. What we see in the periodic table is chlorine 17 and the value of approximately 5.5. So 5.5 is different from 35 and also different from 37. So why is this so? This isotope contributes a percentage of its mass in getting this. This one also contributes a percentage of its mass in getting that. The percentage they contribute into this value is what's called the relative abundance. Maybe this one contributes S% of its mass. This one contributes 100 minus S%, the remaining percentage of its mass to this. So these values, S% and the remainder is what's called the relative or isotopic abundance of an isotope. Now, this value is the mass number, as we call it, mass number, atomic number, atomic number. Now, this one is the atomic number, while this value that has this mass value on it is called relative atomic mass. Mass number, relative atomic mass. The percentages contributed from the masses of this to get the relative atomic mass is not called the relative or isotopic abundance. Having understood that, what is relative atomic mass in chemistry? Relative atomic mass, which I call RAM abbreviation, is the number of times the average mass of a substance is heavier than 1/12 of the mass of one atom of carbon-12 isotope. I repeat, number of times the average mass of a substance is heavier than 1/12 of the mass of one atom of carbon-12 isotope. What is carbon-12 isotope? Standard used for defining relative atomic mass and also another which is called relative molecular mass. Now, why is carbon-12 taken as a standard to define relative atomic mass of every element? It's because scientists define this term using an element that has equal number of protons and neutrons. Carbon-12 has equal number of protons and neutrons. That's why it's chosen as a standard to define relative atomic mass of an element or relative molecular mass of a compound. For instance, looking at this carbon-12, we see that the atomic number is 6. Number of protons is also 6. The mass number, which is A minus Z, is 12 minus 6. So this element has equal number of protons and neutrons, 6. So that's why it's taken as a standard to find relative atomic mass of an element. So having done that, we are going to look at how we can calculate the relative atomic mass of every element when we are given the relative abundances. Looking at this question here, chlorine has 2 isotopes, chlorine 37 and chlorine 35. given that the relative abundance of chlorine 35 is 75%. Calculate the relative atomic mass of chlorine. This is not a problem. To solve it, we have to make our stator work. Chlorine has two isotopes, 37 and 35. And we are doing the percentage of chlorine 35. So we say percentage, which means abundance, of chlorine 35 is 75%. For us to go ahead to solve this, we must also find the percentage of chlorine 37. To get that percent of chlorine 37, how do we get it? We are going to, since there are two isotopes, the sum of their percentage will give us 100%. This is not given to us, you can get this easily. We just say 100 minus 75, that will give you 25%. So we are now asked to calculate or evaluate the relative atomic mass of chlorine. We just apply relative atomic mass of chlorine. How to get it? We multiply each percentage or each abundance by the atomic mass. 75% means 75 over 100 times 35 over 1. We'll do the same for the other one. 25 over 100 times 37 over 1. So when we solve this, we're going to get 35.5, which is the approximate relative atomic mass of chlorine. We'll take expand example. I hope you can see it. Okay, the working is clear. Going to expand example, we have under question, lithium has two isotopes. Lithium 6 and lithium 7 present in the ratio 1:12. Calculate the relative atomic mass of lithium. That's not a problem to solve. We look at this. We look at this problem. Lithium, like the one we took, lithium also has two isotopes. But in this case, we are giving the ratio, not the abundance in ratio, not in percentage. Not to worry, that's not an issue. The ratio of this one is 1. The ratio of the second one is 12. We'll find the sum of ratios, adding them together, we get 13, 12 plus 1. So here it goes. Relative atomic mass of lithium becomes, use the ratio over the